Hello everyone, in this video we're going to be answering this question. I was able to give a string a new value. How are strings mutable? And then I'm going to demonstrate how to use the id function to find the memory address of an object. When we assign a string to a variable, the assigned string is an object. That object is immutable, meaning that object cannot be changed once we create it. So I'm going to create a variable called user_entry, and I'm going to use that variable to store the created object, and that's going to be a string. Now you could hardcode the value as a string variable like this, or any string, but I want to get that from the user, just have a bit more freedom for the user, and they can enter a string. And then what we want to do is just print out basically that value. So I'm just going to have this variable and I want to write it in. So user_entry, and I'm just going to concatenate that string that the user has entered. So what does this mean? This is a string. That string is an object of the data type string. So because this data type is a string, strings are immutable, as we discussed in the previous video. And so we've just assigned this object to this variable. So this variable user_entry now points to this object in memory. So let's give this a little run. Nothing is really big. So we're just putting a value over here and we're printing it out to the user. So this is the object that's being created and it's been assigned to this variable user_entry. This object is immutable. It means we cannot change this object. This object has been created and it cannot be modified. It means I cannot change the value of test into another test, for example. But then, let's have a look at this. But then how is this possible? So I'm just going to copy these two lines and print this again. Okay, but then how is this possible? As in this part, aren't we changing the value of user_entry? So now if I just repeat the same codes over here, I'm asking the user to enter another string again, and then then storing that value into user_entry. So I'm just going to run this again, and I'm going to put in the same value, so test, and then it's asking me to put in another value, another string, but that string, the string that I'm going to enter now, is going to be stored into the same variable that we've used here, user_entry. So if I now say another test, now this object seems like it changed. So previously we said this is immutable, this object is immutable. How is it now another test? Doesn't it look like the value has been changed? Not really. Here is what happened. When we gave the variable user_entry a new value, which is here another test, what we actually did is made user_entry point to a new value. So what happened is a new object has been created, a new string object has been created and has been assigned to user_entry. So now user_entry is pretty much pointing to another object that has this value, another test. So another test is basically a new string object. So in memory, we've actually created two objects, two string objects. The first one was test and the second one was another test. What happened to this value then? Since now another user_entry now points to this object. What about this one? What happened to that one? It's immutable. We couldn't change it, right? But what actually happened is this variable no longer points to this object. But that object still exists. We said it's immutable, it cannot be changed, so it cannot be changed, it's sitting there. So the old value, or string object, test, still exists in memory. If there isn't another variable pointing to this object, so if this is unreachable, if this is an object that is not pointed to by any other variable, then it cannot be reached, so it's unreachable. it will then be destroyed during garbage collection. So it will be taken care of. But it's unreachable. It still exists. It hasn't changed. We haven't modified it. This object still exists. We just can't reach to it because we've made this user entry point to a new object called another test. I hope this really helps you now get the difference, but we can even look into this a little bit further. Can we find out the memory address of the created objects in Python? Yes, we can. We can use the ID function for that. What is the ID function? It is a built-in function that returns a unique ID. Now that unique ID is represented as a long integer. And we're going to see that in a second. So this unique ID is returned by the ID function for an object. This ID points to its location in memory. So let's type in some. So what I'm going to do is I'm going to copy this string again, and I'm just going to show you. Actually, what I want to do is I want to get rid of these lines because I don't want to be creating 4 different strings. So now I'm having the same message to the user. I'm going to change the message that is in the print statement to the ID, sorry, I can't type, the ID of user entry is, and then what we'll have is the ID, and you would put the variable or the object, the variable that is pointing to an object, pass that as an argument. This will return the location in memory. So I'm going to do this twice. What we want to do is we want to observe whether or not we get the same ID for both objects, but we shouldn't, right? Because in memory we've literally created 2 objects of strings. So let's run that and see what we get. So the first time we get tests. So here is the long integer that I was talking about here. Okay, so that's the ID where this object test is pointing to in memory. And then now I'll have another test, and we'll notice that both of these IDs are different. So this is how we know that these 2 strings belong to 2 different objects in memory. So here is our conclusion. We noticed that the IDs of both strings were different, meaning that there were 2 separate objects. User entry is only pointing to one. Which one? The last one, which is this one. And sorry, I spelled this wrong, but you know what I mean. I hope this helped you, and I'll see you in future videos. Thank you so much for sticking around.